I am Anil Kumar. Welcome to my YouTube channel and the website Global Map Institute. In this video, we are looking into application of tangent ratios. There are many. Just to specify, few are related with height and distance and some real life situations. We are going to solve triangles, relate slope with tangent ratio, find angle of inclination of lines, find angle of intersection between lines, and take up many application questions. Just as shown in the figure, we will see how to solve height and distance problem using tangent ratio, which is tan theta is height over distance, opposite side over the adjacent side. Now this is kind of slope or a gradient, so it helps us to find the angle between the lines. We call it angle of inclination. We'll take up a real life situation where the honey bird and the badger collaborate to get honey in nature. Let us watch the video with our student, Rohan. Hi Rohan, how are you doing?
I'm good, sir. How are you?
Very good, very good. So, how is your preparation for your exams going on?
My preparation for my exams are going on fine, sir. I'm able to understand what is happening, like being explained in each topic, and how I can relate it with the other previous topics.
That's very good. So all the learnings you are connecting and then answering the questions in the school without any problems, right?
Yes, sir.
Okay, so today what do you want to learn?
Sir, today I'd like to learn about like the tangent ratio.
Okay, so do you have something to share?
Yes, sir. I have something to
You
share.
can share and then we'll begin from there.
Okay, sir. Can you see my screen, sir?
Yes, I can.
Okay.
Okay, so here we are showing you slope, right? And telling you
Yes,
what
sir.
is tangent ratio. Move on. We'll touch upon all these topics. Okay, ramp examples, correct? Continue. We can continue, yeah. Yes.
Should I also read the key concepts, sir?
Okay, and we'll take some triangles. We'll do that.
And I think that's it, sir.
Is that all? Okay, okay. Now let me take a whiteboard and explain you all these concepts. Is that okay?
Okay, sir.
So I'll share with you a whiteboard, and now we'll talk about tangent ratio. So you remember how trigonometric ratios are defined in a particular triangle, especially the right triangle we normally consider, correct?
Yes, sir.
So let us say we have a right triangle ABC, where at C we have a right angle, right? The sides, as you know, are labeled as opposite to A, we write lowercase a, opposite to B, lowercase b, and opposite to C, it is lowercase c, right?
So, sir, when describing the lower cases, is it okay if I were to say, let's say, for an example, line B, and then for the vertex, like according to angle B, the opposite may be line B, and the adjacent would be
So opposite
line
is the
A?
side, you can say B. B is the length of the side. So when we write ABC, ABC is the length of each side, right? Or you can say the
Yes, sir.
name of the side. So opposite side is A, which is the name also, and also the measurement. So that's the beauty. If I say, for here, let us say, if I say angle A, that means we are talking about this angle. Is that okay?
Okay, sir.
Let's say if angle A is 30 degrees. We're talking about angle A as 30 degrees. I could write now that let B be equal to, let us say, square root of 3. Correct? We say B
Yes, sir.
square root of 3, let us say, right? And then solve the triangle. So now B means the side AC, correct?
Yes, sir.
So let's try to understand this nomenclature. So basically, what I've said here is that in our triangle, now it is not to the scale for sure. Angle A is 30 degrees, which is angle A here. This is C, and this is capital B, and the side B means square root of 3 is on this side. Is that clear to you? Correct?
Yes, sir.
Now, in this particular triangle, can you find what BC is?
Side BC, sir.
Yes.
So would it be, so if it's angle A, right, sir, we need to find out, like,
So we know that this is the opposite side, right? So this is the
yes, sir.
opposite side, and what we are given is adjacent side, correct? So when you
Yeah.
use opposite and adjacent, which trigonometric ratio do you use?
Tan.
Correct. So tangent ratio is basically ratio of opposite side to adjacent side.
Oh,
Okay. So we know now that tan of 30 degrees is equal to BC, which you want to find upon
over
adjacent side of
AC.
square root of 3.
So,
Correct?
sir, would we redo the formula as if would tan 30 multiplied by square root of 3 to get BC?
Yes. So BC will be equals to square root 3 times tan of 30, right?
Okay. Okay, so sir, it's basically like a triangle, like those triangle formulas, right? So like time, distance, and speed.
Yeah.
Like you multiply and divide for each one of them.
Yes.
Okay.
So from here, you can use calculator to calculate this. I will teach you special triangles, and we will find that tan 30 is basically equal to 1 over square root 3, and therefore we'll get answer as 1. So in this particular case, we'll get BC equals to 1, right?
Sir, when we're doing it, are we supposed to calculate it in degrees? That's what you're saying? Because I
Yeah.
also got one as well.
Yes, you're right. So at present, since I gave you the angle in degrees, measurement should be in degrees. By default, for grade 10, you are in grade 10. So in grade 10, we'll use degrees only.
Okay, because the first time when I did it, sir, I got a completely different answer, right, sir? So I was wondering how, but then after redoing my calculator, I was able to get the same answer as you.
Correct. So BC is 1. So now we found what BC is, which is equal to 1. Can you find A to B?
A to B, sir. So then we can do Pythagorean theorem, right, sir? So
Correct.
square root of 3 times no, square root of square 3 times square 1.
Correct. So square root of 3 square plus 1 square square root, correct?
It would just be 4. So
Square root
4
of
square root
4,
of 4 is
which
2.
is 2. And now you also know that this triangle has a right angle at C, correct?
Yes, sir.
Since we know this is 30 degrees, the other angle has to be 60 degrees, correct?
Yeah.
So we have solved the triangle completely. When I say solve a triangle, it really means find the 3 sides and find the 3 angles. Is that clear to you?
Yes, sir.
So let us uh, summarize our learnings from this particular screen. So what we have learned from here is that tan of an angle, let's say angle is theta, is the ratio of opposite side to adjacent side. When we say opposite and adjacent, we really mean opposite side length
Yes,
and
sir.
adjacent side length. Is that okay? But
Yes, sir.
in the class normally, I'll just say opposite over adjacent. Is that clear to you?
Yes, sir.
But we are trying to say the complete thing, which is opposite side length and adjacent side length. Is that clear to you?
Yeah.
And we are working in this particular right angle triangle. Sides, let us say, as we had drawn last time, was ABC, and nomenclature to label the side is lowercase ABC, right? So that is what it is, right? Now, we also learned here that to solve, we could have a trigonometric ratio. So we have combination of trigonometric ratio and also Pythagorean theorem,
Okay.
right? So obviously P capital. So combination of Pythagorean theorem and trigonometric ratios help us to solve right triangles, right?
Yes, sir.
Kind of important to understand. And you also know that sum of angles in a triangle is 180 degrees, right? So when we say sum of angles, let me write down here interior angles. The sum of interior angles of a triangle is 90 degrees, correct? So these are few
Yes.
things which you have to keep in mind while we are working in solving triangles. And when I say solve triangle, we mean what? Find all the three sides and all the three angles. Is that clear to you? So whenever
Yes, sir.
we say solve the triangle, you have to figure out all the 6 parameters of the triangle, which is length of each side and measurement of each angle. Is that clear to you?
Yes, sir.
Okay. So in the last class, you remember in the last class, we talked about basic trigonometric ratio, right? Let me review that also. We jumped into tan theta. So for the benefit of students who are just joining us. In the last class, we learned that we have three primary trigonometric ratios.
Sine, cosine, and tangent.
Yeah. So sine theta, cos theta, and tan theta. Sine theta is the ratio of opposite side over hypotenuse. Cos is ratio of adjacent over hypotenuse. And tan is ratio of opposite over adjacent side. Is it okay?
Yes, sir.
And we also figured out that tan theta is also equal to sine theta over cos theta, right?
Yeah.
And that was simple. Since we know what sine theta is, if I want to find what is sine theta over cos theta, sine theta is opposite over hypotenuse,
And adjacent over hypotenuse.
adjacent over hypotenuse. And as you can see, hypotenuse cancel. What we're left with here is opposite over adjacent, which is tan theta. Is that clear to you?
Yes, sir.
So all this we did last time. And so we jumped into our first example straight into tan theta, correct? Now, in today's lesson, we'll explore applications with tangent ratio. Is that clear to you, right? So
Yes, sir.
there are many applications which we can figure out. One of them, very important, is finding the slope. Now, slope or we say gradient, right? Gradient is also a slope. So as let us say we have a straight line. Let me take this example. This is a very beautiful example. Let us say we have a straight line, whose equation is y equals to 2x plus 1. So if that is the straight line, how do you find slope of the line? Tell me.
It would be rise over run, so y over x.
Right. So slope, which from the equation itself, slope is 2, right?
Yes, sir.
Slope for this line m is equal to 2. So we know slope is 2 for this line, right? How does that relate to tangent ratio? That's what we'll now figure out. Is it okay? So let me just draw some, I mean, write down some coordinate points. Let us say we'll have 3 points. Let's say for x value, we'll calculate the y value, right? Y is 2x plus 1, right? If x is 0, then this will be 1, correct? If x is 1, then it is 2 plus 1 as 3. If x is 2, then it will be 5,
It'll
correct?
be 5.
So plotting these points, we get at 0, we get a value 1. And at 1, we get a value which is
3.
3. And then at 2, we get a value which is 5.
5.
And all the 3 points are actually in a straight line, correct?
Yes, sir.
Okay, so let me just draw a better line so that we connect them. Okay. If I say, how do I relate tangent ratio with this line? You see, if I draw rise over run is this, right? At this any point?
Yes, sir.
So this point here at 0, we have 1. And at 1, we have 3, correct? So what is the rise here? 3
It's
minus
2,
1.
sir.
3 minus 1, which is 2. And the run is 1
1.
minus 0, which is 1, correct? Now, what is this angle theta equals to? Tan of theta.
It would
You see here
2 and 1.
that tan theta is basically equal to rise over run, right? Do you see rise over run?
Yes, sir.
Opposite over adjacent, right? Which basically is 2 over 1, right? Change in y
Yes.
over change in x. Do you see that? So this is basically equal to slope, which is 2 in this case. Do you see that? So therefore, the slope value is also equals to tangent of angle theta. You understand now?
Yes, sir.
Correct? So slope is directly related to tan theta. Correct? Let's explore this particular concept in more details. Let us say we have a line y equals to x plus 5, right? Now the question here is, what angle will this line make with x-axis? Tell me.
So
How
the
can you answer
question
this?
is,
Yeah.
what angle will this line
Line
make with
makes with this
x-axis?
x-axis. Yeah. So we're trying to say we have a line x plus 5, which basically will look something like this, right?
Yeah.
Where the y-intercept at 5, right? So we have to find this angle theta. How much is this angle? This is what you have to answer. How will you do this? Tell me.
To
So what is the
find,
slope of this line? Y equals to x plus 5. What is the slope?
it'll be 1, sir.
And therefore, tan theta is equal to 1. So theta
1.
equals to tan inverse of 1, which is 45 degrees, correct?
Yes, sir.
Since in a right angle isosceles triangle, the theta value is 45, correct? You get the idea?
Yes, sir.
You could use calculator also. but you can get the value just as I have shown. So it is very easy to find the slope of a line, and that way we can also find the angle, right? You get the idea.
Wait, sir. So on the calculator, how would you calculate it though?
Use your calculator to tan inverse of 1. As
So
I
tan.
written, tan inverse of 1, what do you get?
So, sir, if I were to do it right, which button would I click on?
Okay, so we have this shift. Shift button will give you inverse. So tan is normal, and if it is like shift and then tan, it'll give you inverse function.
Shift tan.
And then write down 45 degrees. Is it okay? 45 and then enter.
Inverse tan.
Oh, tan inverse of 1, sorry. Do tan
Yes,
inverse.
sir. Yeah, I got it. I got it. I
You
got
got it
it.
right?
Yeah,
Okay,
it's just my calculator is a bit different, right, sir? So I have to click a different mode to do it.
correct. So we learned last time how do we find the angle. So we just jumped into tan theta. So is this clear to you concept? Slope,
Yes,
right?
sir.
Now let me take another question related to slope, which is a very good application. So we have another line, which is y equals to, let us say, 1 over 2 half x. In that case, find the angle which the line makes with y-axis. Now find the angle which the line makes with y-axis. So if you sketch, it will be easy for you, right? Half
Yes, sir.
x. So this time the line is kind of like this. Slope is not 1 but half. So that is my line, y equals to half x. It goes through the origin, right?
Yes, sir.
Now in this case, we are looking for the angle, which is this angle, which makes with the y-axis, right? So we want this angle theta. You understand?
Okay.
So tell me, how much is this angle?
So basically, sir, what we're finding is we're no longer doing the triangle, right, sir? We're finding out what is the distance between the y and then the line intercepting through
So
point of
yeah,
origin.
we can find the slope, right? Related to the angle which it makes with the x-axis. Let us say this angle here is phi. So tan of phi is equal to half, correct?
Yes, sir.
The slope is same as tangent ratio. So from here, use your calculator and find the angle phi, which is tan inverse of half. What do you get? Round it to one decimal place.
One decimal place.
Shift
I'm not sure if I'm correct, sir, but
tan
I
inverse
got
half.
0.83.
26.56.
Oh, I'm on the wrong one.
Yeah, change your mode to degrees, okay?
Yeah.
So if I have rounded to one decimal place, it'll be 26.6 degrees. Is that okay?
Yes, sir.
So what is the angle theta? If phi is 26.6 degree, the angle theta will be, the angle which it makes with the y-axis will be how much? Tell me.
So 90 subtracted 26.6,
Yes,
which would be 63.4.
correct. So that is how you could find the angle with the y-axis. You get the idea now.
Yes, sir.
Now here is a bonus question for you. On the same principle, why am I taking the example with the line? Mainly because these examples are not in the book, right? So when you will read the book, you will come across all other examples. But this is something which is asked in competitive exams and also as a bonus question in your test paper. So that is how it is going to help you later. You get the idea.
Yes, sir.
Now the question is, look here. We have, this is bonus question for you. We have two lines. One is y equals to, let us say, 2x minus 5 right? We have one line which is y equals to 2x minus 5. And then we also have another line which is, let's take, let me write down this as minus x plus 3. Minus x
Yes.
plus 5, 3, okay?
Okay, sir.
I want you to find angle of intersection. Acute angle of intersection. So when the lines intersect, they'll make acute angle and obtuse angle. You get the idea?
Yes, sir.
So we are interested in the acute angle
Okay.
between the lines. Can you do this? Try to do it. I'll just
Okay,
make
sir.
a small sketch here. I want you to answer this question. This point here will be minus 5. This will be x 3.
3.
So the acute angle we want to figure out, what is the acute angle of intersection between the two lines. So my diagram is not very good. So you need to now figure out how will you find this angle. Use calculator.
Okay, sir. So try to.
Yes. How will you find? Tell me, what is the procedure?
So, sir, what I'm assuming is that first we have to identify what um our slope would be, like our
Yes.
m value.
Yes.
So for equation y equals negative x plus 3, I got m as negative 1.
Yes.
And for y equals 2x minus 5, I got m as 2.
Yes. So if m is 2 for 2x minus 5, which is the line rising, in that case, we can relate that with this angle, right? Angle at E, right? This angle.
Yeah.
So we can say tan of this angle CED. Sometimes we write a cap here saying angle E, right? CED is equal to 2. Is that okay?
Yes, sir.
Now, the other line is y equals to minus x plus 3. Now, that minus x plus 3 is kind of tricky. Angle, when you measure in, remember one thing,
Yes, sir.
angles counterclockwise are positive and clockwise are negative. Do you see that? Is it
Yes, sir.
okay? So this is minus x. So this is tan of, since it is minus, we can look into this angle. Instead of going upward, we can look into this angle. Do you see this?
Yeah.
This angle. So let me say this point here is F. Is it okay?
Yes, sir.
So we are saying tan FD this, right? Or you could say this angle will be equal to that angle, correct?
Yeah.
Both are equal, correct? So in that case, we can say it is CDE, right? Is equal to how much?
Is equal to -1.
Yeah, -1. So what I'm trying to say is you could treat this as as 1 because, okay, because angles are positive, right?
Yes, sir.
Negative basically means giving you the direction. You get the idea.
Okay.
So can you find for tan of 1, you know the angle is 45 degrees, right?
Yeah.
So we know this angle is 45 degrees. Since it is clockwise, it is negative. You understand?
Yes, sir.
Your answer will be minus 45 degrees when you use your calculator.
Okay.
So minus really means that you're looking into the direction as clockwise. Do you see that? So another concept to remember, when you're working on a coordinate plane, clockwise angles are positive. Counterclockwise are positive and clockwise are negative. Is it okay?
Yes, sir.
So you get this angle CDE equals to 45 degrees, correct?
Yeah.
Because they are vertically opposite angles, right? Correct?
Yes, sir.
And how much do you find this angle? CED?
CED if
Tan
1
inverse
is
of 2.
45.
Tan inverse of 2 is how much?
Tan inverse of 2. Yes, sir. I still don't.
Tan inverse of 2 is 63.4. Okay?
Okay.
So we got this angle as 63.4 and that as 45. So you can find the angle in between the two lines. Is that okay?
Yes, sir.
How much is that? 180 degrees minus 63.4 minus 45 degrees. Does it make sense to you?
Yes, sir. Which would just be 71.6.
Do you see how we found the angle between the lines using these concepts? Do you understand
Yes, sir.
what we did here?
So basically, sir, what you first did was from drawing the line, you found the point of intersection, and you use the x-axis on the line to create a triangle, a right angle triangle. And then from
No
there,
right
what you
angle
did
triangle.
was,
I never created any right angle triangle.
oh,
Yeah, we just calculated the angles based on the slope of the line, correct? So let us do it on a fresh page just with the bigger and then summarize our results. Is it okay?
okay, sir.
What we did was we actually drew two lines, correct? Given to us. And let us say that we had one line which was rising and the other line for us was dropping, correct?
Yeah,
So, like this, correct? So, let us say the slope of this line was 2 for us, right? Correct? Since the slope
yeah,
was 2, we know that this angle, let's call this angle now theta, right? So, we know tan theta equals to 2. So, we have theta equals to tan inverse of 2 and we found that value as 63.4 degrees. Correct?
yes, sir.
Now the other slope was -1. So here the slope was -1, correct? So when I use this angle, let us say this angle is phi for me, right? So we do tan phi equals to -1 Pi equals to tan inverse of negative 1, correct? We get minus 45, correct?
Yes, sir.
Now remember one thing, what we have to note here is, let me put a star here. Negative 45 means clockwise direction. Clockwise 45 degrees. Do you see that? It means this. So negative angle signify clockwise rotation. Is that clear to you?
Yes, sir.
So that is why. So, but angle is 45. If you see the magnitude of the angle, it is 45 degrees, correct?
Yeah,
So if this is 45, then vertically opposite angle is also 45 degrees, correct?
45.
And that theta was 63. And we need to find the third angle, which is what we want, this x value. Is it okay? So
Yes,
the
sir.
x value will be equals to 180 degrees minus theta minus 45 degrees, correct? Where theta is 63.4 and we can find the angle. You get the idea.
Yeah.
That is how we can find the angle of intersection between the two lines. You get the idea.
Yes, sir.
So this is a very important question. And this could be asked in a competitive exam or at a higher level. May not be in grade 10, but in 11 or later. Is that clear to you?
Yes, sir.
Correct. So we have seen a very important application which is actually missing from your book. So that's why I spent some time on it so that you understand and we can take more examples from your book later. Is it okay?
Okay, sir.
So here you learn the concept of negative angle. Negative angle basically means clockwise direction, correct? So note. So that means counterclockwise is positive, right? Counterclockwise, positive angle, right?
And then clockwise is negative, right, sir?
Clockwise, negative angle. Correct. So is that clear to you?
Yes, sir.
Perfect. So let me clear this and I'll get into the other slope gradient, which is, let's say, a ramp, right? Ramp is a very good example, and we normally have ramp, which makes things easy to roll or it decreases our work, right?
Yeah.
So, or if there's a hill, we can find what is the slope of the hill, right? Correct? So
Yeah.
ramp or slope. So sometimes you make a ramp so that you make things simpler for yourself. For example, a trolley, right? So a trolley can easily go over a ramp, or a
Yeah.
wheelchair can go over a ramp. But the gradient of the ramp should be very less. I mean, rise over run ratio, let us say, is what we are interested in. We also see ramps in our staircase. You see that staircase sometimes? So
Yeah.
we maintain a ratio of run over rise. You see that? Let us say we have steps. Let us say we have steps so that the step which is horizontal is, let's say, 9 units, and which is vertical is, let us say, 4 units. Is it okay? Then can you find the angle which this ramp makes at the corner? What is this angle? Can you tell me?
Angle theta
Yeah. So you can use tan ratio, tan theta, which is the ratio of opposite side,
over adjacent. So 4 over 9.
4 over 9. And to find theta, you have to do inverse. Inverse is reverse operation, right? So theta is tan inverse of 4 over 9. And we get the value of theta. Let's use the calculator. To use the calculator, first change mode to degrees, right? We're
Yes,
interested
sir.
in mode to degrees. We'll find angle in degrees. Is it okay?
Okay, sir.
And then use shift. There is a key which is shift. And then you press tan and then you press that, with your bracket will automatically come, and then you write 4 divided by 9 and close the bracket and say equal to. So in this case, shift tan, it will show you tan inverse 4 divided by 9 bracket close equal to, and we get 23.96. Let me round this to 24 degrees. Is that clear to you?
Yes, sir.
So we can easily find the ramp in this particular case, the angle which it makes with the horizontal. Is that okay?
Yes, sir.
Now, this concept we do in many problems which are height and distance problems. Here is an example. Let's say we have a ladder. The question is, we have a ladder which is, let's say, 10 meters long, right? Correct?
Yes, sir.
Now, let us say you put this ladder on a building, side of the building. Let's say this is a horizontal plane here, okay?
Yeah.
And the ladder is placed. We know that this angle, maximum, there is a limit to which you can make this angle. It cannot be very steep, right?
Yeah.
If we can have a maximum of 72 degrees angle, let's say this angle is maximum 72 degrees, right?
Yeah.
Then how high can the ladder reach?
How high can it reach, sir? Then that would be opposite over adjacent.
Okay. So because you're doing tan theta, you're doing tan theta, tangent ratio. So in that case, I will, because this will require sine, right? How high the ladder
Yes.
reach? Let's use sine. I will change the question, right? How high the ladder reach? So ladder length is 10 meters, correct?
Yes, sir.
And if the angle is 72 degrees of the ladder with the flow, which is assumed to be horizontal, and building being perpendicular, you have to find the height h. How would you find this height?
So we already know that sine is opposite over hypotenuse, right, sir? And
Yeah,
we already know our hypotenuse, so we can just do is we can make sine 72 equals to h over 10, and
correct,
we can bring it so that we would get h equals to 10 sine 72.
correct. Calculate, what do you get?
So 10 sine 72. I got 9.5, sir.
That is okay. And units meter. Is that clear to you? Of course, it has to
Yes.
be lesser than the hypotenuse. So I assume that to be correct. Is that clear to you?
Yes.
Perfect. So you should remember one thing, that we're talking about height and distance. The questions may not be tan. It could be sine and cosine also, right?
Yes, sir.
Okay. Let me change this question now and we'll continue. Now, this time, let us say we have a ladder. We'll do the reverse calculation, right? On the floor, which is horizontal, let us say we have a building which is vertical at right angles, correct? We'll do
Yeah.
the reverse calculation this time. And let us say we know that the ladder reached up to the height, there was a window here, and it reached up to the height of 9.5 meters,
Okay, sir.
correct?
Yeah.
If this angle was 72 degrees, you have to find how far was the base of the ladder from the building.
Okay, the distance, sir.
Yeah, this, how far was it kept?
So this could be a tangent question, right, sir?
Correct.
So it would be 9.5 tangent of 72.
9.5 will be in the numerator and x will be in the denominator. Since tangent ratio is the ratio of opposite over adjacent, right?
Yes, sir.
So now you'll cross multiply. So x is equals to 9.5 over tan of 72 degrees. What do you get?
I got 3 because I divided 9.5 from tan of 72.
Yeah, 3.086, 3.09, you could say. That
Oh,
is your length, right? That's the 3.08, right? So that's what you get. Now, find the length of, now you find the length of ladder.
the length of the ladder, like the hypotenuse, sir?
Yeah, yeah.
Okay. So it's 3.0 squared plus
So use 3.08, okay?
99.7. Yes, sir. I got square root of 99.7.
Yeah, which is almost 10, right?
Yeah.
Which is approximately equals to 10. You see? So we got the same result as last time you calculated with sine ratio. You see that?
Yes, sir.
So everything comes together. So that is how we could actually solve questions using a ladder. And when we want to estimate how high can the ladder go up, right? Because here the critical thing is the angle which the ladder makes. You see that? We cannot
Yeah.
make it very steep to go very high because then it will skid, correct?
Yeah.
So to avoid the skidding, we have to look into this parameter, correct?
Yes, sir.
Okay. Now, let's take more examples uh, where we could have tan theta. Now, here's a very interesting case. So, so there is a bird, which is we have honey badger, right? Honey bird, and a badger. So the honey bird actually figures out where the honey is. You see, it's a collaboration. So in nature,
Yes.
it is a collaboration. And the collaboration is between the honey bird and the badger. So badger has very strong claws,
Yeah.
but its sensor and badger is not cannot see so far away as the birds can because birds fly and they can see things very far away, correct?
Yeah.
So basically, what happens is that on a particular tree, let us say, so let's say we make a pine tree type of thing, right? Let's make a pine tree, right? So normally birds, honey, they will not. Let's say we have some honey here, okay?
Yeah.
So the honey bird spots the honey. So the story is like this: bird spots honey. So then our badger is somewhere here. So the bird points at an angle that at this angle we have honey.
Yes, sir.
Let us say this angle is theta, correct?
Yeah.
And then after the badger goes, let us say 10 meters, then again the bird points at the honey and gives an estimated angle. Let's say this angle is, let us say, 45 degrees. And let us say this angle is 30 degrees.
Okay.
Your question now is estimate the height at which the honey is there. How much badger needs to climb up to get to the honey? That is the question.
Okay, sir.
How will you do this question? Tell me.
So what I first would do is by looking at the drawing, we can see that the badger is at least 10 meters away before reaching its new distance of 45 degrees. And we already know that theta is already equal to 30 degrees. So what I would do is I would use distance B to C to find the height
How?
using um
This is
uh,
not a right angle. So let's say C to A, assume that to be X. You get the idea.
yes, sir.
Now you see we have two right angle triangles. So one is DCA, other one is DBA, right?
Yeah.
So this is a question which you need to solve and submit. So one right angle triangle, we say the tan of theta, which is 30 degrees, is equal to what? Height, opposite side, divided by the distance 10 plus x, correct?
Yes, sir.
The other angle is 45 degrees. So we have tan of 45 degrees is equal to height over the distance x, correct?
Yeah.
So you have two equations, two unknowns. You can solve this equation, right? Tan 30, we know the angle, correct? And tan 45, we know the angle. So we can calculate what is tan of 30 and what is tan of 45, correct?
Yes, sir.
Round your answer to one decimal place. So calculate what is tan 30 equals to.
10, 30, 57,
No,
57.73.
no, tan 30, no inverse. So tan, do not do inverse, straight tan 30 degrees. You get square root 3 over 3, round it to one decimal place. Let us say two decimal place, 0.58.
Okay.
You get the idea. Tan 30 is 0.577. So round it to two decimal places, it
Yes,
becomes
sir. That's what I
0.5.
got. Yeah, I
Now what is
got
tan 45?
0.577.
What is tan 45? You know tan
10,
45 is 1.
1.
Now you have two equations to solve. And from this equation, you can find the height, correct?
Yes, sir.
How will you find? Tell me.
So what we have found is from tan 30, we found 0.58 and tan 45 is 1, sir, correct?
Correct.
So when we're using it, would we use it as the distance between each other?
So we have equation 1 and equation 2, right? So this is our equation 1, correct? And this is our equation 2, correct?
Yes, sir.
So from equation 2, how are h and x related? They are equal, right?
Yeah.
Because the ratio is 1. So you can say x is equal to h and substitute here. So we have h over 10 plus h equals to 0.58, correct?
Yes, sir.
Now you can cross multiply and find the value of h. You understand?
Okay.
So h equals to 0.58. I'll write h first, plus 5.8, right? 10 times. And bring it together. So h minus 0.58 h equals to 5.8. So that gives you the value of h, correct?
Yeah.
H equals to 5.8 divided by, what is 1 minus 5.8?
1 minus 5, 0.42.
0.42, right? Calculate. Oops.
I got 13.8, sir.
So, yeah. So just calculate. So let me just.
Yeah, I did. I got 13.8.
Okay, that's the answer for a height, right?
Yeah.
So, wait. Divided by,
So 13 point.
So from here you get h as 13.8 as you're saying, right?
Yes, sir.
Do you see
Therefore,
how
X
we
should be
solved it?
13.8, right, sir?
Yeah, so that is the estimated height at which the honey is located. Do you see how we have solved this complicated case, which is indeed a real life situation, and where the estimate has been made based on the information given by the bird to the badger? Do you see that?
Yes, sir.
So, this is a very good example. We have solved a kind of a situation, height and distance problem, where we have involved two triangles, two equations, and you learn how to solve simultaneous equations. Based on those concepts, we had our solution. Is that clear to you?
Yes, sir. So today I've learned how to what tan theta is, how I can calculate it, and in various examples, seeing real life examples. For an example, the honey badger, the honeybird and the badger, and how they were able to get honey, and
Yeah.
also looking at how I can calculate the angles, along with knowing how I should calculate a full triangle from its Pythagorean theorem to the angles and distance.
Right. Okay, great. And then CN Tower project, you have to make your own question, build on what I gave you some rough outlines, correct?
Yes,
So
sir.
that you could actually measure accurate height of CN Tower. Let's say to whole 10 meters, nearest to 10 meters. Is it okay?
Yes, sir.
Okay, great. Thank you. Have a great
Goodbye,
day.
sir.